Okay, now we'll look at some indices. This is things that are to a power. Usually we call the number on the bottom the base and the number on the top the power. So for example, 2 to the power of 3, 2 is the base, 3 is the power. That means 2 times 2 times 2. Okay, so the first index rule is this one, that when we multiply two bases, we add the powers. And actually that makes sense, because if we had, for example, 2 squared and we want to multiply it by 2 cubed, well, 2 squared means 2 times 2, 2 cubed means 2 times 2 times 2, there's 5 of them, so that's 2 to the 5. A quick way is you just add 2 and 3 to get the 5. And you can use that process for all of these rules here. You can go back to the original long way of writing it out, or you can use this quick way of using these rules. So the first rule is when you multiply bases, you add the powers. So using that rule for question 1, we will get the answer to this being 5p10, because the 7 and 3 add. This one here, you always put the numbers out the front. Here the power 4 and 3 will give 7, so 2d7. This one here, 4 3s are 12. We don't add the numbers, we still multiply numbers as usual, but when we have bases, like the same base, cc, you add the powers of those c's, which is 5. This one here, 9 5s are 45. But looking at the bases, now there's no power there, but there's an imaginary 1, because a to nothing really means a to 1. So that's a to 1 plus 2, which is 3. 6 8s are 48, and we've got m1 m1, which is m2. This one here, 7 6s are 42, and we've got q appearing in 3 places. We just add them all. 3 plus 9 is 12, plus another one is 13, so it's q13. This one here, the j's, do the j's separately, so that's j17, and we've got the k cubed sitting there by itself. This one here is a cubed, because you've got an a2 and an a1, and a b2 and a b1 is b cubed, or b to the power 3. This one here, you've got f to the 9, 6 and 3, and the g to the 5. And here we've got x5, that's 4 and 1, and y7, 6 and 1. This one here, we bring the 3 out the front, then do the x's, you got x cubed, and then you do the y's, you got y4. Now the second question is using the second rule, and the second rule is this one: when you divide bases, you subtract the powers. Once again, you can use it with the long way, which if we had, for example, 2 cubed and I divided by 2 squared, well, 2 cubed means 2 times 2 times 2, 2 squared means 2 times 2, and you can see they cancel, leaving 1 2, which is 2 to the 1. Well, a quicker way is just do 3 take 2 and you get the 1. So rather than using that long way, we're going to use the quick rules for algebra. Down here we've got that divide sign is really means that you have a fraction sign there. So that's k cubed divided by k squared, and you take the powers, so it's k to the 1, or just k. This one here, 7 take 2, that's m5. This one here, notice the 3 is on the bottom, so we don't want to put the 3 up the top. We keep the 3 on the bottom, or we could call it a third, and we do the c's. Now we could write this as c, 7 take 9 is minus 2. So we have the line there, we do 7 take 9 giving minus 2, and the 3 still sits on the bottom. You could write that the same way. You could say that's a third c minus 2. We're going to learn later what that minus 2 can be replaced with. 4a5 on a, so that's 4a4, 5 take 1. This 6 divided by 2 is 3, and 5 take 2 is 3. This here is 4, and the y's will give y1, and the n just stays as n. Now 6 divided by 18, that's 3 on the bottom, not on the top. We've got g cubed on the top, and h11 and h4, we have h11 take 4, which is 7. So g3h7 on 3. And h, we've got 4 divided by 8. So we'll actually write this as a fraction first, so that's 4x squared y divided by 8x squared y cubed. Now 4 divided by 8 puts a 2 on the bottom, and the x squareds cancel, the y1 and take the y3, that'll be y minus 2, 1 take 3. Okay, now we go over to rule 3, and this time we're going to use the first, second and third all combined. Now the third rule, the additional rule for the third rule, is anything to the power of 0 equals 1. You can put that in the calculator. If you put 2 to the 0, you'll get 1. Once again, that makes sense. If you've got 2 squared, that means 2 times 2. 2, 1, that means 2 times itself. 2, 0, there's nothing we can have, and by definition it's 1 for everything. Okay, so the first question, 6 to the 0 is 1, a to the 0 is 1. This one will give m10 on m2, which is 10 take 2, which is 8. This one here, 7 take 7, so that's a to the 0. A to the 0 is 1, 1 times 3 is 3. This is 3 2s is 6 divided by 6 gives 1, and on the top you've got P5, and on the bottom P2, so P5 and P2, and then that'll simplify to P3 when you subtract them. This one gives 6 on the top and 12 on the bottom with the numbers. If you look at the letters, you've got C5 on the top, and on the bottom you've got C7. And then when you divide them, 6 divided by 12 is 2, so it's 2 on the bottom, and 5 take 7 is minus 2, so it's C minus 2. This one here is 3 2s is 6, 6 divided by 6 is 1. If you look at the x's, we have x7 and a y, and on the bottom x squared and a y. The y's cancel, giving 1, and the x7 and x2 gives x5. Now we go on to the fourth rule. The fourth rule is anything from a power to a power of a power, you multiply the powers. So using that rule down here, you multiply these two powers and it's A12. This one here is 7 to the 3 times 0, which is 0, and that's 1. This one here will be D12 times D10, which equals D22. This one's C6 on 3C9. Now the 3 stays on the bottom, 6 take 9, so we have C minus 3. 2 divided by 6, that's 3 on the bottom. And you've got B12 on the top, and on the bottom we have B18, 9 2s are 18. Now 12 take 18 is 6, but it's on the, so it's minus 6 all over 3. 6 divided by 2 is 3. If you look at the F's, we have F12, F6, F18 and a G. Now if you add these F's on the top, we get F18, and we got F18 on F18, so they give 1, so it all cancels down to 3 on G. Okay, number 5. When you've got two bases to the same power, you can actually give the power to both of the bases individually. So this one here is going to be A3B3. This one will be 4 given to the first, 4 given to the second, and we multiply them through just like the rule 4 showed us. So that's going to be D12, E8. This one here, you get the 2 goes with both of these, so it goes with the 3, so it's 3 squared, and it's x8. 3 squared is 9, so it's 9x8. This one here is 2 to the 4 times by b to the 8 times by a to the 12, so that's 16 b8 a12. E, 4 squared, so that's 4 squared times by g6 times by h2 over 2 cubed times g6 and h12. Now 4 squared 16 and 2 cubed is 8, and 16 on 8 is 2. The g6 and g6 cancel, and the h2 and the h12, that's 2 take 12, which is minus 10. Okay, the sixth rule is if you've got two bases inside being divided, the power goes in with both of those bases. So this one here, you'll have a cubed and b cubed. The power goes in with both of them. This one here is 2 to the 4, r to the 4, s to the 4. This one here is 3 cubed, p6 on q12. This one is f6 on 2 squared g8 and times by 2 cubed times f6 on g cubed. That can be simplified. You've got 2 cubed on 2 squared, so that's going to give 2 to the 3 take 2, or 2 to the 1 or 2. f6 and f6 is f12, and the g8 and the g3 is g11. Last one here is going to be m18 on n12 times n6 on m squared. Looking at the m's, we're going to have m16, 18 take 2, and looking at the n, 6 take 12 minus 6. Now the last index rule is the negative rule. The negative rule says when you got a negative, you put it on the bottom and put a 1. Also, you could extend that to this concept. If you've got a fraction ab all to a power, to a negative power, all you do is you flip the fraction upside down, and then you change, and that'll be changed to a positive power. Or this rule here, when you've got a minus, to get rid of the minus, it's 1 over that. Okay, so looking at this one down here, that's going to be 1 over a1. This is 1 over a squared. This one here is 1 over a cubed. This one here is 1 over 2c to the 1. This one here is 1 over the whole thing, c squared d cubed. Instead of the minus 2, it's to the 2. Now you could simplify, go a little bit further with that. That's 1 over c4 d6. This one here is we could use the quick way where we flip that upside down. That's just a on 1. The minus just flips the fraction up the other way. This one here, you flip that upside down, that'll be b on a. This one here, you flip upside down, so it'll be q4 and 3p squared. This one here, get rid of the minus, you flip it upside down, q4, 3p squared, but we've still got the 3. We've got rid of the minus by flipping it, but we've still got the 3, so you could actually expand that and make that q12, and that's 3 cubed, or 27, and p6. And j, once again you flip it, 2p cubed, and q minus 2, and that's, instead of the minus 3, it's to the positive 3. So that's going to give 2p9 over q minus 6. Now that minus 6, we could then take that up the top, so it's 2p9, because minus 6, getting rid of the minus takes it down or up, so that'll be q6. Having learnt this minus concept, we could go back and actually change some of these where there's minus signs, now that we know this rule. For example, this one, just doing a different colour, this one here, that is now, we could write that as a third 1 over c squared, because the minus 2 puts it on the bottom. Another one would be here. All of this here is really 1 over y squared, and we got the 2, we keep the 2 on the bottom, so it's 1 over y squared. Another place where minus was is here, so that's 1 over 2c squared, and this one here will be 1 over 3b6. This one here would be 2 over h10, the minus puts it on the bottom, and this one here we have m16 over n6. The minus takes that down to the bottom. Okay, so that covers all the rules, all the 7 rules. There is like a problem solving sort of a question on 8, combining factorisation with indices. Just do that one quickly to finish off. We can take out a common factor of x squared, and so you're left with x squared plus 1 divided by x squared. They cancel using indices, or just dividing, and so the answer is x squared plus 1. Likewise, this one we could take out a common factor of 3x squared, and you're left with x squared plus 4 all over 3x, and using we could divide the 3's out, and using indices rules, x squared divided by x, 2 take 1 is 1, so it's really x to the 1. So it's x times x squared plus 4. So that's how indices can come in useful when we're trying to factorise and simplify algebraic expressions like this. Okay, it's quite involved. The more practice you do at those, the better you'll get.